Hey everyone, and welcome to this explainer on the empty set. Have you ever searched a shopping app for, say, a brand new laptop under $5 and the results screen is just completely blank? Well, that is exactly what the empty set is in mathematics. If you ever feel kind of intimidated by math, seriously, take a deep breath. Today, I'm going to be right here guiding you through it logically, almost like your own private tutor, so you leave here feeling absolutely confident.
Okay, let's just take a really quick look at our roadmap for today. We're going to cover matching sets and descriptions, discovering the empty set, some step-by-step practice, and finally, a super common exam mistake you definitely want to avoid.
All right, moving right into part 1, matching sets and descriptions.
We're going to start by looking right at question 8 from our textbook here. It's a classic matching exercise where we take a really simple list of items and just match it up with its written mathematical rule. Honestly, it's a great way to see how math is really just a language.
So look how easily we can translate a simple list of numbers into a rule. In roster form, we just have the numbers 2 and 3 sitting in those curly brackets. But in set builder form, we ask for an x such that x is a prime number and a divisor of 6. And since 2 and 3 are literally the only prime numbers that divide perfectly into 6, these two forms are describing the exact same thing. It's just two different ways of stating the facts.
Okay, part 2, discovering the empty set. Let's get into it.
I want you to imagine a physical container in front of you. Now, if our mathematical rule asks us for natural numbers smaller than 1, we actually have to stop and think for a second. Natural numbers are basically just counting numbers, right? 1, 2, 3, and so on. So we quickly realize there are literally no natural numbers smaller than 1. So what goes into our container? Absolutely nothing. The container just stays completely empty. And that brings us to the crucial point here. Mathematicians actually have a special name and symbol for this exact situation. It's called the empty set. You might also hear it called a null set, or even a void set. It basically just means a set which doesn't contain any element whatsoever. And because mathematicians absolutely love their shorthand, it's denoted by a really specific symbol. It's the Greek letter phi, which looks like a circle with a diagonal slash right through it, or you can literally just draw an empty pair of curly brackets.
Here are a few more kind of fun logical paradoxes straight from the text that result in empty sets. Take a look at set A, looking for a natural whole number that falls between 1 and 2. It just doesn't exist. Or look at set B, finding a rational number where x squared minus 2 equals 0. Or set D, finding an odd number that, when squared, equals exactly 4. Well, 2 squared is 4, sure, but 2 is an even number. So because none of these criteria can actually be met, all of these are perfectly empty sets.
Awesome. Moving on to part 3, step-by-step practice. All right, here's our first problem, and it's a nice, easy one. It asks for the set of integers which lie between 2 and 3. Is this an empty set? Justify your answer. Now, don't worry at all if word problems look a bit tricky at first glance. We're going to break this down piece by piece.
Let's methodically see what's given and what's actually being asked. Step 1, we identify that the rule is looking for integers, which just means whole numbers, right? Between 2 and 3. Step 2, we logically analyze the criteria. So ask yourself, are there any whole numbers strictly greater than 2 but less than 3? Well, no. There are fractions and decimals in there for sure, but absolutely no whole numbers. So step 3, we logically conclude that since no such integers exist, the set remains completely empty.
See? Great job. Now let's look at this next medium-level problem together and just apply that exact same calm logic. Problem 2 asks about the set of natural numbers that are smaller than 1. Is this an empty set? Let's run it right back through our 3 steps. Identify the given. We need natural numbers smaller than 1. Analyze the criteria. Well, by defining our terms carefully, we know that the set of natural numbers universally begins at the number 1 and goes upwards from there. So, our conclusion? There are absolutely none smaller than 1, leaving our set perfectly empty once again.
Okay, for our final, slightly harder board exam level example, let's carefully read the rule about remainders here. Problem 3 asks, the set of odd numbers that leave a remainder 0 when divided by 2. Empty set?
I love this one because it brilliantly illustrates how just recognizing your basic definitions quickly solves the problem. Step 1, the given. Odd numbers perfectly divisible by 2. Step 2, we analyze it. By mathematical definition, any number that leaves a remainder of 0 when divided by 2 is an even number, right? It is literally impossible for an even number to also be an odd number. So step 3, we conclude.
This total contradiction means no such number exists. It has to be a null set.
And finally, Part 4, a common exam mistake.
I really want you to notice this comparison closely. Phi, or those empty curly brackets, represents a set with exactly 0 elements inside it. However, placing the number 0 inside the brackets means the set contains exactly one element, the number 0 itself. The absolute biggest mistake students make under exam pressure is confusing an empty set with a set that actually just contains the number 0.
To put it as simply as possible, phi and the set containing 0 are two completely different things. Think about it like this. An empty cardboard box is very, very different from a box that has a wooden block sitting inside of it with the number 0 painted on it. That first box is genuinely empty, but the second box, it clearly has one item inside it.
I really want you to keep that visual locked in your mind. If someone asks you to write an empty set on your next exam, are you going to draw an empty bracket, or will you accidentally trap a 0 inside? Remember this quick mental cheat sheet. 1. Empty sets have 0 elements. 2. They are written as phi, or empty brackets. 3. Natural numbers start at 1. 4. Even and odd rules always apply. And 5. The surprise trick. A 0 in a bracket is not an empty set. It's a trap. Just trust your logic, and I guarantee you'll absolutely conquer set theory. Thanks so much for learning with me today.